Hello friends, welcome back to my channel Maths by Samit Deshmukh. In this video we are solving remaining 5 examples from question number 3 of exercise 1.5. In the last video we have completed first 7 examples, and in this video we are solving example number 8, 9, 10, 11 and 12. So if you are new on my channel, so please subscribe the channel and hit the bell icon to get notification of every newly uploaded videos. And if you like the videos, please share these videos with your friends also. See, in this example, one function is given to us, y is equal to log of x plus under root x square plus a square raised to power m, and we have to show that value of this expression will be equal to 0. If we'll observe this expression, we will require the value of dy by dx and d2y upon dx square, and once these values are known to us, using those we will try to show that value of this expression will be equal to what? 0. So first we are differentiating this function with respect to x. Here we can observe that the function is logarithmic, so first simplify it using laws of logarithm. According to laws of logarithm, this power m can be taken as coefficient, so here we will get m into log of x plus under root x square plus a square. Just simply applying laws of logarithm, this power we have taken as a coefficient. Now we are differentiating it with respect to x, so differentiate with respect to x, so derivative of y is dy by dx. If you will observe this side, m is a constant term, keep it as it is. This term is in the form of log f of x. And what is differentiation of log f of x? 1 upon f of x. F of x is what here? X plus under root x square plus a square into derivative of f of x. F of x is again x plus under root x square plus a square, isn't it? So which is equal to, now m into 1 will be equal to m upon x plus under root x square plus a square. Just we have differentiated it applying which formula? Log f of x. So its differentiation is 1 upon f of x. This whole term is f of x into derivative of f of x, isn't it? Now we have to find out derivative of this term. So observe here, two terms are connected by plus, so here first we are finding derivative of x, that will be equal to 1. Now to find out derivative of second term, we can observe here that second term is in the form of which formula? Under root f of x. So its differentiation is 1 upon 2 under root f of x. What is f of x here? X square plus a square into derivative of f of x, means derivative of x square plus a square, isn't it? So which is equals to m upon x plus under root x square plus a square, keep it as it is. Now here 1 keep it as it is, plus also as it is. We are finding differentiation of this term. Here a square is a constant term, so its derivative is 0, and derivative of x square is 2x, means derivative of this whole term is equal to 2x, and 2x into 1 will be equal to 2x. So here we will get 2x divided by 2 under root x square plus a square, isn't it? And here we can observe that 2 and 2 from numerator and denominator will get cancelled. So which is equal to, so here m plus x plus under root x square plus a square, keep it as it is, isn't it? Keep this first term as it is. So now here we are taking cross multiplication. Let us see what we will get after taking cross multiplication. Under root x square plus a square into 1 will be equal to under root x square plus a square, and here nothing is in the denominator, means 1 is there. 1 into x will be equals to x, and in the denominator 1 into under root x square plus a square is equal to under root x square plus under root x square plus a square. This result we have obtained just simply by taking what? Cross multiplication. Now here we can observe that this x plus under root x square plus a square and this x plus under root x square plus a square will get what? Cancel. These two terms will get cancelled. After cancelling these two terms, on the left hand side what we are getting here? Dy by dx, and on the right hand side write down the remaining term. These two terms will get cancelled, means in the numerator m is the remaining term, and in the denominator under root x square plus a square will be the remaining term, isn't it? Now I am shifting this term on this side, because if you will observe this result, this term appears on this side. So on this side we will get under root x square plus a square into dy by dx. So this term will get multiplied on this side. On this side remaining term is m. Even we can observe our required result here, square root is not there, and since square root is not there, so we are squaring both sides. If we are squaring both sides, let us see what we'll get here. So here root will get eliminate? First write down here square on both sides. So if you are squaring both sides, on the left hand side here root will get eliminate and we will get x square plus a square, and square of dy by dx will be equal to dy by dx whole bracket square, and on this side we will get m square. This result we have obtained just simply squaring both sides. Now we are differentiating it because in our expression second order derivative also appears. So differentiate it with respect to x, On this side, to find out the differentiation, we have to apply product rule. According to product rule, keep first term as it is, x square plus a square as it is, into derivative of second term, means derivative of what? Dy by dx whole bracket square, plus second term as it is, means dy by dx whole bracket square as it is, into derivative of first term. What is first term here? X square plus a square, and on this side derivative of m square will be equal to 0 since it is a constant term. Just we have applied product rule, first term as it is, derivative of second term plus second term as it is into derivative of first term, and on this side differentiation of constant term is 0. So here x square plus a square, keep it as it is. Now we are finding its differentiation. It is in the form of f of x raised to power 2, means first we have to take power of f of x as an coefficient, so take 2 as an coefficient, then decrease power of dy by dx by 1. If you are decreasing power by 1, the new power will be 1, into derivative of dy by dx, means derivative of dy by dx is it d2y upon dx square. Yes, d2y upon dx square. In this way, applying which formula? F of x raised to power n, we have obtained the derivative of this term. First take power as an coefficient, decrease power by 1, then derivative of dy by dx is d2y upon dx square, plus now here derivative of x square is 2x and derivative of a square is 0, so derivative of whole term will be equal to 2x, and I am multiplying by 2x to dy by dx whole bracket square. On the right hand side keep 0 as it is, so differentiation is completed. Now we have to simplify it to get our required result. In our first term, x square plus a square is there, and also d2y upon dx square is there, means we does not want 2 dy by dx, so we will try to eliminate 2 dy by dx, and if you will observe the second term, x is there and 1 dy by dx is there, means here also we have to eliminate 2 and 1 dy by dx, and here also we have to eliminate 2 and dy by dx. So that's why in both the term 2 dy by dx appears, so simply dividing both sides by 2 dy by dx we will get our required result. So divide both sides by 2 dy by dx. Let us see what we will get after dividing by 2 dy by dx. If I am dividing to first term, 2 dy by dx and 2 dy by dx will get cancelled. Remaining term is x square plus a square into d2y upon dx square. Now divide to the second term. If I am dividing to second term, 2 and 2 will get cancelled, and 1 dy by dx from the square will get cancelled, means remaining term is x dy by dx. On the right hand side 0, keep it as it is, and easily we can observe that this is nothing but the result which we have to prove here. So in this way we have completed this example number 8th. Now see, in the 9th example, given function is y is equal to sine m cos inverse of x, and here also we have to show that value of this expression is 0. So we have considered the given function, again we are differentiating it, and we are trying to find out first order also and second order derivative also. So differentiate it with respect to x, so let us see what will get. Dy upon dx is equal to, function is in the form of sine f of x. What is differentiation of sine f of x? Will be equal to cos f of x, this is f of x, m into cos inverse of x, into derivative of f of x. F of x is what here? M cos inverse of x, isn't it? So function is in the form of sine f of x, so its differentiation is cos f of x into derivative of this f of x, isn't it? Just we are applying the formula to find out derivative of composite function. Cos m cos inverse of x, keep it as it is. Now here m is a constant term, keep it as it is. What is differentiation of cos inverse of x? That is minus 1 upon under root 1 minus x square. Now first order derivative is known to us, just we are simplifying it. Here minus 1 into m is minus m, I am writing here minus m into cos of m cos inverse of x, and parallelly I am shifting this term on this side because this term appears on this side. So on this side we will get under root 1 minus x square into dy by dx. Now again we are differentiating it with respect to x. So on this side, to find out differentiation, we have to apply product rule, since product of two term is there. So keep first term as it is, means under root 1 minus x square as it is, into derivative of second term is derivative of dy by dx is d2y upon dx square, plus second term as it is means dy by dx as it is, into derivative of first term. Derivative of first term means here derivative of under root 1 minus x square. Okay, so this result we have got simply applying the formula of what? Applying which rule? Product rule. Now on the right hand side, minus m, keep it as it is, minus m as it is. Now we are finding this differentiation. Check that it is in which formula? It is in the form of cos f of x. And what is derivative of cos f of x? Will be equal to minus sin f of x. What is f of x? M cos inverse of x, isn't it? M cos inverse of x into derivative of this f of x, means derivative of m cos inverse of x. Again observe, minus m is a constant term, keep it as it is. Function is in the form of cos f of x, so its differentiation is minus sin f of x into derivative of this f of x. Okay, so on this side keep first term as it is, means which term? Under root 1 minus x square as it is, d2y upon dx square also as it is, d2y upon dx square, then plus dy upon dx also as it is. Now here we can observe that this term is in the form of under root f of x. What is derivative of under root f of x? So its derivative is 1 upon 2 under root f of x. What is f of x? 1 minus x square into derivative of f of x, that is derivative of 1 minus x square, isn't it? On this side, minus into minus will become plus m. Again observe, minus m into minus will become plus m. Then sin m cos inverse of x, keep it as it is, m cos inverse of x. And lastly we are finding differentiation of this term. Here m is a constant term, keep it as it is, keep m as it is, and we are finding derivative of cos inverse of x, which is nothing but minus 1 upon under root 1 minus x square, isn't it? So differentiation is completed on the right hand side. Here only remaining part is to find out derivative of this term, isn't it? So here under root 1 minus x square into d2y upon dx square, keep it as it is, plus dy upon dx also as it is. What is derivative of this term? Is it minus 2x? Yes, derivative of 1 is 0 and derivative of x square is 2x, means minus 2x. So minus 2x into 1 is minus 2x divided by 2 under root 1 minus x square, isn't it? So differentiation of this whole term is completed. Now observe the right hand side very carefully, which is equal to, now here minus 1 into m is minus m into m is minus m square, and this term sin m cos inverse of x can be replaced by y. Let us denote it by equation number first. We are replacing this term by y from which equation? First, from first, and remaining term is here 1 upon under root 1 minus x square, isn't it? Here m into m will become m square, minus we have written here. This whole term we have replaced by y and keep this term 1 upon under root 1 minus x square. Now differentiation is completed. Now we are simplifying it to get our required result. To get our required result, just simply, here we does not require root, and here on this side root, the same term under root 1 minus x square is in the denominator. Now to eliminate this term, and here to eliminate this square root, because on this side here only plus m square y is there, because minus m square y on this side will become plus, but we does not require this term, means we have to eliminate this term, and that's why I am multiplying both side by under root 1 minus x square. And I think after multiplying by under root 1 minus x square, definitely we will get our required result. So multiplying both sides by under root 1 minus x square. Let us see what we will get after multiplying by under root 1 minus x square. Now multiply to the first term by under root 1 minus x square. Under root 1 minus x square into under root 1 minus x square will be 1 minus x square. d2y upon dx square, keep it as it is, isn't it? Now here after multiplying to the second term by under root 1 minus x square, under root 1 minus x square, and this under root 1 minus x square will get cancelled. Even here 2 will also get cancelled. Minus x into dy by dx is minus x dy by dx will be the remaining term. And now we are multiplying to right hand side by under root 1 minus x square. So under root 1 minus x square and under root 1 minus x square will get cancelled. Remaining term is minus m square y on this side, which will become plus m square y is equal to 0, which is nothing but the result which we have to prove. In this way we have shown that the value of this expression will be equal to 0. Now see the example number 10th. In this case, what is the given function? Y is equal to log of 2x, and we have to show that value of this expression is 0. In this case, y1 and y2 appears, means y1 is first order derivative and y2 means what? Second order derivative. So we are differentiating this given function with respect to x to find out first order derivative. I am denoting derivative of y by y1. Generally we are denoting derivative of y by what? Dy by dx, but this is another notation for differentiation. First order derivative, such type of notation appears in the result. That's why we are denoting first order derivative here by y1. On this side, to find out differentiation, we have to observe the given function which is in the form of log f of x. What is derivative of log f of x? 1 upon f of x, where f of x is log 2x into derivative of f of x means derivative of log 2x. Again observe this side is in the form of log f of x, and we know that its differentiation is 1 upon f of x into derivative of f of x. So which is equals to 1 upon log 2x, keep it as it is, log 2x as it is. Now we are finding its differentiation. Again we can observe that it is in the form of log f of x. So its derivative is 1 upon f of x. What is f of x? 2x into derivative of f of x. What is f of x here? 2x, isn't it? Derivative of log f of x is 1 upon f of x into derivative of f of x. Just we are applying standard formulas to find out the differentiation. 1 upon log 2x, keep it as it is. Here 1 upon 2x also as it is. What is derivative of 2x? Will be equal to 2. Here easily we can observe that 2 will get cancelled, and on this side y1 keep it as it is. If you observe required result, x appears on this side. That's why this x I am shifting on this side. So on this side we will get x into y1, and remaining term on this side is 1 upon log 2x, isn't it? So now again we are differentiating it with respect to x. To differentiate it, we have to apply product rule on this side because product of two function is there. So let us try to find out differentiation of this left hand side applying product rule. According to product rule, keep first term as it is into derivative of second term. What is the derivative of y1? It is denoted by what? y2. First term as it is, derivative of second term plus second term means y1 as it is into derivative of first term. What is first term here? X. Okay, on this side we have applied what? Product rule. Now observe the function on the right hand side. Now here we can observe that this function is in the form of 1 upon f of x. What is derivative of 1 upon f of x? Its derivative is minus 1 upon f of x square. F of x square means square of log 2x into derivative of f of x. F of x is log 2x here. Log 2x. Again observe here function is in the form of 1 upon f of x, and derivative of 1 upon f of x is minus 1 upon f of x square. Sorry, here f of x square is there, means square of log 2x. Square of log 2x into derivative of log 2x. Okay, now let us simplify it. On this side x into y2 keep it as it is, x into y2 as it is, plus y1 into 1, derivative of x is equal to 1, and on the right hand side minus 1 upon log 2, log 2x whole bracket square as it is. Now we are finding differentiation of log 2x. We can observe that this function is in the form of log f of x. What is derivative of log f of x? 1 upon f of x. F of x is 2x into derivative of f of x means derivative of 2x. Derivative of log 2x is 1 upon 2x into derivative of 2x, isn't it? So here x, y2 keep it as it is because this is our first required term, plus y1 into 1 means y1. Here y1 into 1 means y1. We have got second term also. Now simplifying it, we have to we have to get what? y1 into y1 is square of y1, square of y1 into x. That will be our required result. Simplifying this another side. So here minus 1 upon log of 2x whole bracket square, keep it as it is, minus 1, minus into 1 is minus 1, and here 1 upon 2x also as it is, and derivative of 2x will be equal to 2. Now 2 will get cancelled, so which is equal to minus 1 upon, now we does not require the term of log 2x, isn't it? So that's why we are replacing this term, and for that purpose I am using this equation number what? Let us denote it by equation number first. So here better way, write down this term as square of 1 upon log 2x. Yes, square of, minus already we have taken on one side, square of 1 will be equal to 1, and square of log 2x will be square of log 2x, isn't it? So here this term 1 upon log 2x, 1 upon log 2x, its value is xy1, its value is what? xy1. Keep this square as it is, just we are substituting the value of 1 upon log 2x, 1 upon log 2x from which equation? First, its value is xy1, and here remaining term is 1 upon x. So which is equal to minus as it is, square of x is x square, square of y1 is y1 square into 1 by x, keep it as it is, here x and 1x from numerator will get cancelled, so remaining term is x y1 square. Now keep this left hand side as it is, x y2 plus y1, and this minus term on this side will become plus x y1 square. On the right hand side we will get 0. So here x y2, keep it as it is. From these two terms we are taking simply y1 common. Let us see what we'll get if we are taking y1 common. Why we are taking y1 common? Just to arrange the term in the form of this result. Here also y1 they have taken common. If I am taking y1 common from first term, so here its coefficient is nothing is there, means 1 is there, and here x, keep it as it is. From this y1 square, if we are taking y1 common, so here remaining term is y1, isn't it, is equal to 0, and check that is it our required result. In this way we have solved example number 10th. Now see the example number 11th. In this example, one homogeneous equation is given to us, x square plus 6xy plus y square is equal to 10, and we have to show that its second order derivative is 80 upon 3x plus y whole bracket cube. So we have considered this equation, so we can easily observe that such type of function is called as what? Implicit function. So first let us try to differentiate it and find out first order derivative. So we are differentiating this given function with respect to x. So let us see what we'll get here. Derivative of x square will be equal to 2x. Here 6 is nothing but constant term, and to find out derivative of x into y, we have to apply product rule. According to product rule, keep first term as it is, derivative of second term is derivative of y, plus second term means y as it is, into derivative of first term means derivative of x, isn't it? And plus derivative of y square, it is in the form of f of x raised to power 2. First take power as an coefficient, then decrease power of y by 1, then derivative of y is dy by dx. So derivative of y square is known to us, and derivative of 10 will be equal to 0, isn't it? So now here 2x, keep it as it is. I am multiplying by 6x to both the term in this bracket. 6x, 6 into x is 6x, 6x dy by dx. Here first term will be 6x dy by dx. Now here derivative of x will be equals to 1, and 1 into y is y, and y into 6 will be equal to 6y. Okay, and this plus term, keep it as it is, 2y dy by dx is equal to 0. Now our aim is to find out value of dy by dx. That's why we are collecting the terms of dy by dx. Two terms of dy by dx are there. If we are taking dy by dx common from these two terms, see what we'll get. Here its coefficient is 6x, and here its coefficient is 2y. On this side plus 2x will become minus 2x, and plus 6y will become minus 6y, isn't it? So dy upon dx will be equals to, take minus common here, so what we'll get here, 2x plus 6y, just simply we have taken minus common, and this term is multiplied on this side, it will get divided. So here we will get 6x plus 2y, just simply this term will get divided on this side. In this way we have got the value of dy by dx. Let us check again, is it possible to simplify it? Yes, we can observe that all the terms in numerator and denominator are divisible by 2. So we are getting what result if we are dividing by 2? So here minus as it is, if I am dividing to numerator by 2, here we will get x plus 3y, and if I am dividing to denominator by 2, here we will get 3x plus y. This result we have obtained just simply dividing to numerator and denominator by what? 2. Now let us denote this equation by equation number 2, which is nothing but value of dy by dx. To find out second order derivative, again I am differentiating it with respect to x. So differentiate it with respect to x. On the left hand side, derivative of dy by dx is d2y upon dx square. On the right hand side, keep minus as it is, keep this minus as it is, and now we are finding differentiation of this term applying quotient rule, means u upon v. First we are just substituting the values in the quotient rule. According to quotient rule, v keep it as it is, means 3x plus y as it is, into derivative of u. What is u here? U is nothing but x plus 3y, isn't it? Minus v as it is, derivative of u, minus u as it is, means x plus 3y as it is, x plus 3y as it is, into derivative of v. What is v here? V is 3x plus y. चलो यहाँ पे स्पेस नहीं है, थोड़ा समझने की कोशिश करो. And in the denominator we will get v square. V square means square of 3x plus y, isn't it? Just simply we have substituted the values in the quotient rule. V as it is, derivative of u, minus u as it is, derivative of v divided by v square. V is nothing but 3x plus 2y. So which is equal to, चलो अब क्या करते हैं, minus 1 upon, ये term को एक side में ले लेते हैं. So means we are taking what? Minus 1 upon 3x plus y whole bracket square. ये denominator को हमने एक side में ले लिया है, so that we are able to simplify it. So here we will get 3x plus y, isn't it? Now here derivative of x is what? 1, and 3 as it is, derivative of y is dy by dx. Okay. Now here minus x plus 3y, keep it as it is. Now we are finding its differentiation. Its derivative will be equals to, I am writing derivative here, just try to understand. Derivative of 3x is 3 and derivative of y is what? Dy by dx. Okay. So which is equals to, इसे थोड़ा साइड में ले लेते हैं, minus 1 upon 3x plus y whole bracket square. Okay. Now we are substituting the value of dy by dx. We are substituting the value of what? Dy by dx. Here we have got the value of dy by dx. Just try to understand here. 3x plus y, keep it as it is. Here 1 also as it is, 1 also as it is, and here dy by dx, its value is already minus. Minus into 3 will become minus 3, and x plus 3y divided by 3x plus y, isn't it? Again try to understand it. So here 1 keep it as it is, and we are replacing dy by dx by this value. Minus into plus will become minus, keep this 3 as it is, and write down that term x plus 3y upon 3x plus y. Means simply we have substituted the value of dy by dx, and here minus x plus 3y, keep it as it is, minus x plus 3y as it is, and here 3 also as it is, replace again dy by dx by its value, minus x plus 3y upon 3x plus y. Just simply we have replaced dy by dx by its value, isn't it? और ये square bracket यहाँ पे close हो जाएगा. So which is equals to, now minus 1 upon 3x plus y whole bracket square, keep it as it is. Now I am taking cross multiplication here. We are taking what? Cross multiplication. Keep this term as it is. 3x plus y as it is, and let us see what we will get if we are taking here cross multiplication. So here 3x plus y into 1 will be equal to 3x plus y, and minus 3 into x is minus 3x, minus 3 into 3y will be minus 9y, and in the denominator we will get 3x plus y. Okay, and here let us see what we will get. Keep this term minus x plus 3y as it is, minus x plus 3y as it is, and here also we are taking cross multiplication. If we are taking cross multiplication, see what we are getting. 3x plus y into 3 will be 9x plus 3y, and here minus into x is minus x and minus into 3y is minus 3y. This result we have obtained just simply by taking cross multiplication. 3x plus y in the denominator, keep it as it is, isn't it? So now we can easily observe that denominator of both the terms are what? Same. So we are taking subtraction of this numerator. Check what is denominator here, x plus 3y, and here also x plus 3y. Since denominators are same, take the subtraction of numerator. Remaining part I am writing on this side. So now keep this term as it is, which is equal to minus 1 upon 3x plus y whole bracket square. Keep it as it is. Keep this term as it is. Now here already we have discussed denominator of both the terms are same. So denominators are same. What is the denominator here? 3x plus y. Since denominators are same, simply we are taking subtraction of numerator. Let us see what we will get here if we are taking subtraction of numerator. Okay. So now here we can observe that plus 3x and minus 3x will get cancelled. Now I am multiplying by 3x plus y to both these terms. Let us see what we'll get. First I am multiplying by 3x. 3x into y will be 3xy. 3xy. Then 3x into minus 9y will be 3 into minus 9 is 27, and x into y is xy. Minus 27 xy, isn't it? Now I am multiplying by y to both the term. Y into y is y square, and sorry, here check it a better way. First collect these two terms, okay, and later on we will simplify it. So hope you are getting it. So here y minus 9y, is it equal to minus 8y? Yes, minus 8y. Minus 8y into 3x, minus 8y into 3x will be minus 24xy. Minus 8y, here their difference is what? Minus 8y into 3x minus 24xy, and minus 8y into y will be minus 8y square. Minus 8y square, isn't it? Means this simplification will be minus 24xy minus 8y square. Now here check what we will get here. Here which terms will get cancelled? Plus 3xy and minus 3xy will get cancelled. 9x minus x will be minus 8x, and I am multiplying by minus 8x to both the terms in this bracket. So 9x minus x will be 8x. 8x into minus will be minus 8x. Minus 8x into x will be minus 8x square minus 8x square, and minus 8x into 3y is minus 24xy. Minus 24xy, isn't it? So which is equal to, now in the denominator, 3x plus y into 3x plus y whole bracket square into 3x plus y will be square of 3x plus cube of 3x plus y. Here power of 3x plus y is 1, and here power of 3x plus y is 2. Since base are same, we are taking addition of power. 2 plus 1 will be equal to 3. Now here minus, we can observe that all the terms are negative, isn't it? So I am multiplying by minus to all these terms. Can I say that then all the terms will become positive? Yes, because sign will get changed since I am multiplying. So I am multiplying to this term by minus, so here we will get plus 8x square. Again observe here minus 24xy minus 24xy is minus 48xy, and minus 48xy into minus will become plus 48xy. And lastly minus 1 into minus 8y square will be plus 8y square. Now we have, according to our required result, in the denominator we have got 3x plus y whole brackets cube. What is required term in the numerator? 80. So let us try to get 80 in the numerator, which is equal to, now if we are taking 8 common, because we can observe that from all the term we are able to take 8 common. So which is remaining term here? X square. Here we will get 6xy, because 8 6 are 48, and here we will get y square. Just simply we have taken 8 common from the numerator. In the denominator 3x plus y whole bracket cube, keep it as it is. This is nothing but value of what? d2y upon dx square. So therefore d2y upon dx square is equal to 8, keep it as it is, in the denominator 3x plus y whole bracket cube as it is. Now if you'll observe this given condition, so what is the value of x square plus 6xy plus y square? Will be equal to 10. So replace x square plus 6xy plus y square by what? 10. So I am replacing it by 10. Already in solution we have denoted this expression by equation first. So write down here from equation first, and which is equal to 8 into 10 will be equal to 80 divided by 3x plus y whole bracket cube, which is nothing but our required value of second order derivative. Now see the last, means 12th example from this question. So in this case, value of x and y in terms of t is given to us, means given function is parametric function, and here we have to prove that this is nothing but value of second order derivative. So first let us try to find out first order derivative. So first we have considered the value of x, since t is the parameter, that's why we are differentiating x with respect to t. So here we will get dx upon dt. On this side, a is a constant term, derivative of sin t with respect to t will be cos t, minus b as it is. Now we are differentiating cos t. What is derivative of cos t? Will be equal to minus sin t, isn't it? So let us simplify it. A cos t minus into minus will become plus b sin t will be the value of dx upon dt. Now consider y, and y is equals to, what is the value of y here? A cos t plus b sin t. Now we are differentiating it with respect to t. Differentiate with respect to t. So derivative of y with respect to t is dy upon dt. On this side, a is a constant term. Let us try to find out derivative of cos t. Derivative of cos t will be equal to minus sin t plus b as it is, and derivative of sin t with respect to t will be equals to cos t. In this way we have got the value of dy by dt also. Once both the values are known to us, now find out value of dy by dx. So which implies that dy upon dx means first order derivative. According to theorem on parametric function, it can be written as dy upon dt divided by dx upon dt. So which is equal to, in the numerator we are substituting the value of dy upon dt, which is nothing but minus a sin t plus b cos t, isn't it? And in the denominator substitute the value of dx upon dt, where dx upon dt is a cos t plus b sin t. Okay, now we are trying to convert it in terms of x and y. So to convert it in terms of x and y, here we can observe that this a sin t minus, if I am taking minus common from numerator, so this negative term will become positive and positive will become negative, and we will get a sin t minus b cos t, which can be replaced by x. And here clearly we can observe that this denominator is nothing but value of what? Y. Now simply we are taking minus common from numerator, so dy upon dx will be equals to, if I am taking minus common from numerator, so negative term will become positive, means minus a sin t will become plus a sin t, and plus b cos t will become minus b cos t. In the denominator, a cos t plus b sin t, keep it as it is. So dy upon dx will be equals to, dy upon dx will be equal to minus, this numerator can be replaced by x and this denominator can be replaced by what? Y. So minus x upon y will be our first order derivative. Let us denote it by equation number first. Now question is to find out second order derivative. So again we are differentiating it with respect to x. So differentiate it with respect to what? X. So derivative of dy by dx is equal to d2y upon dx square. Okay, just we have converted this example in terms of x and y. We have eliminated parametric function. We have converted it in terms of x and y from the given values. Now to find out derivative of this side, we have to apply quotient rule. Here minus, keep it as it is, keep this minus as it is. Even in our required result also we will require minus here, so we are not disturbing to minus. Now here differentiation can be found out applying quotient rule. So according to quotient rule, v as it is into derivative of u means what, x, minus u means x as it is into derivative of y means dy by dx. In the denominator, v square means y square, isn't it? So which is equal to minus, keep it as it is, otherwise take this y square from denominator on one side. Just simply y square we are shifting on one side. So here y, keep it as it is, what is derivative of x, 1, minus x as it is. In our required result, dy by dx does not appear, so I am replacing dy by dx by its value. What is the value of dy by dx? Minus x by y. So minus x by y, this value we are substituting from equation number first. So from first we are substituting this value. So which is equal to minus 1 upon y square, keep it as it is. Here y into 1 will be equal to y, minus into minus x will be equal to plus x square upon y. Okay, now we are taking here cross multiplication. Let us see what we'll get. Minus 1 upon y square, keep it as it is. So here we will get y square plus x square plus x square divided by y. Just simply we have taken here cross multiplication. So which implies that d2y upon dx square will be equals to, we are not disturbing to this minus, keep it as it is. In the numerator, x square plus y square plus x square can be written as what, x square plus y square, and in the denominator y square into y will become y cube. And check that is it our required value of second order derivative. In this way we have completed all 12 examples from this question. If you think that these videos are helpful to you, so please like the videos and share these videos with your friends also. In the next video we are starting last question from this exercise 1.5.